So let me go up. Okay, so we worked out mostly with these options. So maybe I assume you must have got now idea about these all things with respect to mod RM byte. Correct? This is a 32-bit. Okay, is it 30? No, sorry, 16-bit. Yeah. This one actually each one of you must have got idea about how this mod 11 really works. Fine, and almost all the cases we would be getting most of them. After this, if you see the above part, okay, for ESP nothing is written, correct? For ESP nothing is written. For ESP and EVP is nothing is written. So they are not permitted to be used at that particular point of time, because they are specific registers with respect to what you can call it as stack. Okay, related to procedural execution or process execution, that or program execution. So they would be having their own special role to be played by each of one of them. That's why they would not be considered. Only they would be considered with respect to immediate or and or probably uh, register to register. Now, what are the query that was sent by the student? Like if I try to see the screenshots, those were sent. The student has included their square brackets and that thing. So we haven't yet addressed. So as that mod is not coming into picture right now for us, so I will address them after a while. So even the same query was by him or her probably was with respect to say a register. Okay, and even with respect to AL and so on. So whenever what are the mechanisms that we have seen rather with respect to the data or with respect to the registers that we applied. So if I take say for example 1403 ASM, this was the code that we wrote, and we saw only these two kinds of instructions right now. We haven't addressed yet other instructions. Okay, while considering the translation. So when time comes, I definitely would be addressing that part. Don't worry about it. So even if you are trying something on your end, yes, you are welcome. You can definitely do that, but keep patient, be patient, so that we definitely will understand each and every component of what you can call it as generating the addresses, even generating the opcodes and so on. So is that okay? So I don't know like who those two students are, but I can read the numbers. Are they present here? Like if you put one query to me, you can definitely unmute and let me know. Mobile number of 89990422109. Who is having that mobile number? Yes, please. Okay, Gnanesh Patil. Okay, another person, I assume Tushar. Tushar also sent that. So we'll definitely work with this. So he was talking about 8-bit register. So let us see what happens there. Okay, so I'm taking now the code. Sorry. Okay, so let us take this code. Now we know that at both the places, so like we have taken it as immediate value. If you see here, we have something written like this AL, correct? AH. So we got B8 there for EAX with 0A to be your ID. For EBX, we got BB because it adds register number into B8, correct? Same case would be true for 16-bit registers too. Fine. Now the thing comes into picture when we do talk about B0, correct? So let us talk about that move instruction for 8-bit value. Fine. Okay, so for reference purpose, let me add one more thing. Fine, let us take this too. You will see here that I have declared a variable. I have declared 3 variables there. Okay, of different sizes. So first one is seems to be integer. Okay, because it takes 4 bytes. Second one seems to be a variable requiring 2 bytes, and third one can be thought of as an character or a byte. Fine. So if I translate this, let us see the code. Correct. Now you will see here the opcode taken for each of them. Here we can see there is C6. There is this you are seeing there 05. Okay, and then you are having something here. Fine. So like this is not register. These are memory. So this if I go to this move instruction where there is something different and we are getting 05. Let us see how exactly it is represented. So let me go to move. Okay, and let us try to talk about the B8. We all know immediate 8-bit value, 32-bit data. So 32 RM32. Let us see this. What was that? B8. Correct. You can see here. Correct. Move instruction is taking it as immediate value with B8. Now register number would be added because of this plus RD, and that's why this BB is coming into picture for EBX. Fine. Now if let us take this B0. So if I see here, let us see B0. This is B0. Register 8 plus immediate 8. So even the register number would be added. So if I really talk about, okay, so let me take edit again. So we said that our order of registers would be what? EAX, ECX, EDX, EBX, ESI, sorry, ESP, EBP, ESI, EDI. Now for 8 bit, at the same point of time, it would be AL, CL, DL, BL, AH, CH, DH and BH. Now where can we see this? So if you go to page number 36, probably. Yeah, here. You can see that. See, AL, CL, DL, BL, AH, CH, DH, BH. With EDI, we can see BH. With ESI, we can see DH. Correct. So that's what I did here. You can compare this thing. Correct. So what are the numbers are? So numbers associated with these registers are same. So first number is 0, then 1, sorry, 2, 3, 4, 5, 6, 7. Now, if you see what are the opcode that we are getting for these three instructions, AL and C. So if I see this AL 10, AH10, BL10, BH10. So this 10 is taken as a byte. That's why this 0 is can be seen in both the places. Same thing, 10, 10, 0 is seen. So if it is B0, so if I go to that move instruction, B0 was meant for, let us go below. Yeah, B0 was meant for B0 plus register number. So what is the value for AL in this file? What is value for AL?
0.
0. So you add 0 into that. Now when we talk about AH, what is value for AH?
4.
So you add B0 plus 4. What you are get? What you are getting? B4. Correct. Similarly, let us talk about BL. What is number for BL? 3. So B0 plus 3. So that's why this is B3. Correct. And B0 plus BH. BH is 7. So that's why 7. So at least we can conclude now. We know now this thing. Are you with me? Are you with me with this part? Why 66? Why 66 was added there? It was 32 bit, correct? Sorry, it is 16 bit. That's why that this thing came into picture. And data is organized that way. Like how many bytes are required? As it is AX, so 2 bytes. That's why 10 is added like this. Here it is 32 bit. That's why 10 is added like this from 0A. Correct? And here in this case it is requiring only now. Now the part would be this. Okay. Now let us go to this kind of instruction where there is C7. So if you see, it says RM32. Now when I say RM32, it would be mostly the memory. Correct. Now if I try to do same thing, say for example, if I go to Emacs. Correct. Now let us see. So what it is saying? Invalid effective address. So 2 lines we are getting that error. Now the thing behind this is like if I see the code, line number 22 and 23. So it would be mostly the last lines. Now your memory cannot be considered like this. Memory is already always a 32-bit value. 16-bit address can never be part of it. So that's why this never occurs here. Correct? This never occurs. You cannot write like this. You cannot write like this even. Now, if at all you want, you keep a variable which is of like word. So that's what we did here. Sum1, which was got translated. Sum2, which was a byte that got translated. But you cannot take the registers in between. Now if I try to see what is this, if I okay, let me take this one and let me add different register here, say EDX, and let us see what is the change. Now the error would be removed. Now see the code. Okay, let me maximize this. Yeah. In both the cases, you are having C7, correct? C7. This is your 0A. This is your 0A. And you definitely can see that that register number is added there. 00 and 02. Correct? Because EDX is 2, na? As per our text, EDX is 2. Correct? But now, when we do say this, how exactly it is mapped? Here, assumption is that EX is representing some memory. EDX is representing some memory. That's what it is saying. And when we took a variable, it took address of it. So if I see here, like when I wrote all these three cases, if I see some, first address is 000. That's why you see here. Correct. Then someone which was a byte, sorry, double word address is 04. That's why this 04 is written in that way, in the same Little Indian notation. And last one was 6. So this is 6. But there is something else added. This would be SIB. 050505 in each cases. How exactly it is to be computed, we'll work out. Don't much worry right now for a while. Okay, but let us try to concentrate on that C7 now. Now see what C7 says. You have /0 immediate 32. So if this it is represented by a register, then how exactly it is to be used? Okay, so let me try to write it. So let us go here and let us open this text file. Now our code, like I will write that number 05. How you will write 05? 0000 0101. Correct? This was for your first set of instruction, like when you used a variable, either a word, double word, or double word, or a byte. We see 05 there. Correct? 05 there. But for variables, we do see 00 and 02. So let me write at that as well. 0002. And if you see with C7, it is having /0. So right now, let us work out this. Let us write 000 1 1 2 3 1 2 3 0 0 0 0 0 0 1 0. Now what is 1 0 here? If 1 0 means 2, correct? 2 is EDX. And you can see that this instruction is using EDX. And as it is having /0, so this part remains 0 with respect to what we saw in the previous session. But you will see that mod is not 1 1. Mod is 0 0. Mod is 0 0. So whenever though register is used, but you are referring to the address which is of a 32-bit value. Address is 32-bit every time. What value you are picking from that address is different story. Now in this case, we are picking value as an a byte. We are picking value as an a word. We are picking value as an a D word. But address is 4 byte only with 32-bit architecture. And that is the reason if I now let me go back to my PDF. Okay, let me go to that page number 40. Now see here. This mod is 0 0. Now see these registers. So whenever you are using displacement 32, so you would be seeing these values, some of these values. So what value we got there? For some 05. Correct? 05. You can see that 05 is occurring here. Displacement 32. But you may say then like it is talking of something like this, that we are getting value. But in that scenario, whenever you are taking mod, one parameter would be like this. So now suppose, okay, let me know when you are not getting. So suppose let me write like this. Let us see what happens there. D word of sum comma eax. Fine. Let us try to translate this. Now we do see A3 here. Because EAX is there, that's the reason. And we saw in move instruction, move instruction A3 here. Register is there and memory offset. It is a 32-bit address. This sum in this case is representing a 32-bit address. That's why this offset 32 came into picture. Correct. So let me replace it by some other register now. Instead of EAX, now let me take it as, okay, let me remove this blanks so that you can see that in a single window. I made it ECX. Now let us see. Now when it is EAX, then separate treatment. But when it is other register, then you are saying 0D. So mod comes into picture. Now if you see in that same row where exactly we saw this 05, in the same row you should see this 0D because this is register that you have. And as for sum, it is taking 05. For EAX, it is having different opcode without mod RM. Now you can see I am referring to same table where we saw 05. Next to that 05, 0D should be there. Okay, let me check. Yeah, 05, now 0D. Because you are talking about displacement 32. Correct. And you are referring now which register is here? ECX. Now if I take ESI there, then I should get 35. Correct. I should get 35. Let us check. I am taking ESI there instead of ECX. Let us see whether are we getting 35. Can you see 35? Yes.
Yes, sir.
Now if you see carefully, for each of these cases, whenever your mod RM byte occurs here between 00 to 3F, it would be in serial order 0001, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Then you have 10, 11, 12, 17, 19, 1A and so on till 3F. Mod, whenever you are getting mod RM to be like this, in that every situation, mod would be 0 and you are referring something like this. You never will write ESP there. It would not be taking that one. This would not be considered there. So if you write ESP, what may happen? Let us try. It will translate, but at runtime, probably it may give you some error. Okay, let us see. So instead of this EAX, let me write ESP. Let us see what it does. Now see for ESP what it did. So this is 0A. Correct. Now I can see that there is 04 and 24. So 04 above 5. This is 04. So though it is not saying that it would be ESP, but it is referring to something which is stored on a stack. But after 04, I do see that there is something else added as 24. Now say that kind of treatment was not given to other registers the way that I do see EDX here. I use the similar thing. Instead of ESP, I use EDX. But I can see that it took only C702 and then my immediate data. But when I wrote ESP, then it suddenly made a change. It was adding something more. Now I don't know what that 24 means right now. We have to definitely dig into and find out what exactly this 24 refers to. Correct? What that 24 refers to. So let us think of a conclusion. Mod 00 will come into picture whenever your operand, one of the operand is like this. Second operand could be immediate value. So if immediate value is there, then you definitely will see always 05 there. For memory, you will see always 05. And if the operand, like when I say some kind of variable, if you use the way that you declare variable in data and VSS, if variable is picked from that place, then always you would be seeing 05 you used. But if apart from that, if you are using registers like EAX, ECX, EDX, EBX, ESI, EDI as one of the argument or one of the operand and other operand is register, then you definitely will see these registers. So these values would be there for these all registers. So if I take combination of move in square bracket EX comma DL, then I should get 10. Not DL, but ultimately EDX. Okay, let us try this and see whether are we getting it. In square bracket EX and EDX is second argument. What we talked about, we want this 10. Can you see 10? So now you use any register here from EX till EDI. This line would be there 0, 0, 0, 8, 10, 18, 20, 28, 30, 39, 38. Same thing would be true when I replace EX by ACX. If I replace by EDX, if I replace by EBX. Then what happens when I took EBP and ESP? Okay, so we already have considered, sorry, we already considered case for ESP, correct? Here. I will write this one. I will write this one. Okay. I will write EBP. I will write here EAX. EBX. Let us see. So though you don't do this in practical writing, program writings. Okay, but yes, definitely. Let us see at least what kind of translation is. So ESP comma 10, EBP comma 10, you can see 0424 was here added. Then your 0A started. So 10 was started. Same thing. We see 45 00 and then 000 is. So these things are not considered. So if you see 04 and 45. So where is 45? 45 goes here. So you are adding EBP in bracket. So displacement 8, EBP plus 0 actually it is. So this 45 came here and mod suddenly got changed. Though you wrote only EBP in bracket, it is actually EBP plus something. So EBP plus 0 now in this case. That's why this 00 even probably might be added. We will see how exactly that 00 get formed. Even how get 24 get formed. Now if I talk about this EX and EBX, same thing. 8, 9 is part of it. So 04, 24. We see the same thing here. Only difference between these two is If immediate is there, then immediate would be following that. So if you see, though the opcode is different, C7 and 89, because we are talking about EX here or a register here. That's why this 89 came into picture. Correct. 0424 was kept same. This 24 was kept same, but we see 1C there. Now what this 24 means? Right now we don't have any idea about this 24. The way that we are seeing 24 here, the way that we are seeing 00 here. We don't know what exactly it is. But our problem is now, at least, okay, not a problem, but at least one can say, whenever I do see anything added in square bracket like this, then my opcode should be picked from this. So now I hope you understood mod 00. Any questions you can ask? Tushar, I hope now I resolved your queries with respect to that AL part.
Yes, sir.
Because square bracket would be referring to something else, though I haven't used directly that byte part. So I tried showing you below this thing. Like if you write something else here, then what? We can do that. Definitely. We can work with. But you don't write like this. You should not rather write like this. Tactically. Yeah. Any other question? Yes, please. Hmm? अरे पूछो जल्दी यार, कुछ भी पूछते नहीं हो मतलब फिर दिक्कत होती है मुझे। तुम्हें समझा नहीं समझा मुझे पता नहीं चलता है। So I'm hoping now as you are not responding, that means you are getting everything. Assumption. Fine. Okay. Now let us try something different. So let me first add this code to chat. So now I mod 11 and mod 00 is done. So we'll be talking about now next point, next type of mod. Mod 00 will be considered when one has a operand in fine. So I'm adding this file only for reference purpose for you peoples. So okay, so let us go now, or let us talk about other things. So yeah. So I will now close this. So now I'm writing one simple code. Okay. Say for example, I want array ready, sorry, not ready, dd 10, 20, 30, 40, 50. Okay. Section.bss and ready one section dot. I'm writing a simple code. Okay, I'm trying to show you how exactly I can print this array. Fine. So push keyword of ebx plus. Okay, I only see what exactly is happening, then I will explain the code. Let us see. Okay, sorry, I wrote a message. It should be print. So I added 4, 5 values there, but it printed 4. Correct. So we can correct it. So okay. Yes. Jump if greater or equal. That's what I said. Earlier it was jump if 0 means 0 got there. So if I see like what exactly happens there, let us see. Dash g dash app bar. So display $ESI. Next instruction. ESI became 0. Okay. N is 5 probably. We will not be able to print it. So let us display EBX. My EBX would be address. Okay. So if I try to examine data of EBX, currently it would be 10 because this is address now. So when you write this kind of instruction, ultimately this is an immediate value, which would be an address. Okay. An array is declared in your data section. Fine. So that's why you can see here EBX is holding something, and whenever we write examine display in decimal contents of EBX, because EBX is containing an address, we want contents of that on that address. So we got 10. So if I write here EBX plus 4, EBX plus 8, EBX plus 12, and EBX plus 16. So these 5 values. So we want that ESI to be incremented by 4. That's what we are doing. Okay, so let us see next instruction. So step, and we are adding ESI there. So EBX plus 0, then EBX plus 4 would be right. So step, add ESI comma 4. Yes. Now if I write examine slide D $ESI plus $EBX, you can see it is 20, and that's what we are doing now there. Here EBX plus ESI, correct? So now I should see 20 value displayed, correct? So you have entered 20, correct? Now let us do this. Add ESI comma 4. So 4 plus 4, 8. So let us see this. Next value is 30, correct? Step again. 30 would be printed. You entered 30, correct? Step. Now ESI would be 12. So if I write this, it would be 40. So step. You entered 40, correct? Now if you see how I wrote the code, check this code. Okay, not from here. Okay, leave apart that EX. So it is not playing any role there, but I should have written there ESI instead of this move ESI comma. Even let me show you how the difference is between the amount of code that gets generated. Now both the statements, this one and this one results to same thing, ESI comma 0. This also is ESI XOR. Same value if you XOR with itself, this will be 0. But what is the difference between both of these instructions? So though we know that opcodes are different, but try to concentrate on number of bytes taken, and you will appreciate that when you see that you have to really worry about how many bytes it would be taking to represent this. So this would be taking nearly 5 bytes. This would be done in 2 bytes. Okay, let us see. See, this is done in 2 bytes, and this is with 1, 2, 3, 4, 5. So 2 bytes and 5 bytes. You may say what we are achieving with 3 bytes, and optimization does the same thing. Optimization does the same thing. Correct. So because you want less amount of code should be loaded in memory. When I say less, it should not hamper anything. So if I try to say now, let us generate the thing. Okay, let us debug the code. Sorry, I haven't linked GCC and then debug the code. Breakpoint main display $esi run esi. This also 0. Now even if you write ni, this also would be 0 because we haven't made any change there. Okay, ultimately both the statements are resulting to same result, like having 0 value with the register, but the difference between both of them is what? Number of bytes taken, and you definitely should think over this, because I always say this whenever you are asked to write a code with assumption that you are writing code in C. Without understanding what the problem statement is, you already written main integer ijk lmn char ch. You always write this. You don't care whether are you going to make use of those variables at the later stage. It is really important. So you may say hardly what we are doing. We are declaring memory. I have ample memory available there. You are having ample memory, but to whom you are writing the code, to whom for you are writing the code, he may or may not have that amount of memory there. Correct? Fine. So that's the reason, like it is always better to write good code. I assume you have a course right now called algorithms, where you do really talk about designing algorithms. But what about making use of data structures? How efficiently the data structure can be used would be an important part. So simply choosing writing any data structure doesn't resolve the issue. You have to choose a better data structure to represent that part. Are you with me, everyone? So don't take this like in a granted manner that you have data structure. You already did that data structures in your bachelor's course, but you should do it rigorously while writing the code, because choice of data structure really matters no matter in which field you are into. When I say in which field, I mean to say in industry. How exactly you want to represent the system. Fine. Is that okay? So I expect you to try at least this mod 00 part. Okay. Let us not much worry about what comes later. Like we saw 24 something or this displayed. We'll worry about it later. Right now, only try to see that you are getting mod there. So whenever you are talking /0/1, mod definitely is part of it. Mod RM is definitely part of it. Fine. Okay. See you then tomorrow. And so we'll try to have a lecture probably a bit early tomorrow. I will let you know what time, and we will take probably 2 hours, because we would be talking not exactly 2 hours, but more than an hour or so. I hope we are having lecture in the evening, correct? Am I right? Or we don't have lecture
Yes,
tomorrow?
yes.
So we'll have. I will let you know what time I will be taking. Fine. Thank you very much, and be